Hello, Dr. Sakwa. I think you're on mute. Maybe you can start over.
Oh, okay. Thank you. So welcome. Today we're looking at, we continue with our class on Circom programming language. So as I was saying, after writing a zero knowledge proofs, the next thing will be you want to prove whether it's correctly written and then verify. And so before that, you have to input a witness because that is what will be helping us to in the proving and then verification process. I just wanted us to recall what a witness is. And I want to give an example. Supposing we have Z as, let me say, A, B, C. Let me say A times B times C. We need to come up with a witness, first of all. But before that, we have to ensure that this equation is in a rank 1 constraint format. So for you to do that, you need to, first of all, come up with the intermediate values. For instance, you can say let B1 be A times B, so that finally Z becomes B1 times C. So this is now what you will enter in your circle. This is what we shall now write. Now, but what I want is what is a witness that we shall then be computing. Our witness, we said we write in the form, is supposed to be in the form 1, then the output. Our output in this case is Z. Then you would put the inputs A and B, and then C. Those are our inputs. Then if we have intermediate values like V1, you would then include them. So these are witness. But of course, these witnesses will be assigning it values, integers. What I mean here is, supposing somebody said he knows the decomposition of Z, where Z is 90. So this person knows the factorization of Z. So the factorization of Z are then what we call AB. So maybe this person should tell us it is 2, maybe times 3, times something else. So those are the witnesses. So this person, if you had to enter a witness, and I'll be showing an example, you're giving us, no, you don't give us 1. You don't give us this will be computed by, Z will be computed by the values you put. So you just put just put the inputs ABC, and then V1 will be computed directly by the program. When you run it, it will itself find V1, and then it will also find Z. So you only put the inputs, but the rest, this program, when you run it, is supposed to compute V1, supposed to compute Z, and so on. Now, but now, where we're beginning from, beginning with how do you then input your witness? That is our point today, because when it comes to identifying witness, that one we have no problem. We've done that before. Now, so after your program, after you've written your circuit, you go to the terminal and then run this command, Circom multiply, where the multiply here, you remember this part. Remember, this is the file name. The file name, if your file is multiply.circom, this is the file name. You can change this file name to be something else. The first part here, you can change it to be something else, but it must be .circom. We've done that before. Then rank 1 constant system, symbols, and then the WASM. Now, so of course, we went through what this does and what this does. These are the flags. We've got the flags and what they do, and even this WASM. But we are interested with this. This is what will open for us a file where we will then input our witness. This WASM. So you must include it there if you want to input your witness, because it's this that will then open that file where you then input your witness. Now, so briefly, I've just highlighted what each of these flag will be doing, but of course, we've already done that. I've said, okay, I have said that this command, when you use this command, then it will give us the rank 1 constant system, it will give us the symbol mapping, and then it will give us this file, multiply _js. So this multiply is just coming from the name of the file, how you saved your program, how you saved your code. And I said you can always change this. If you want it to be addition, multiplication, for instance, you can change this, but it's .com, not .circle. Now, so this multiply comes from there. It will be _js. Now you will then go here, you will CD this. I'll show you the steps. You'll CD this. And when you CD this, you go inside and then open a file. And that file, we shall call it .json. And it's there. We will then input. That's what I've said, _js. Then after you CD that, you go inside and open a file, then input your witness. So let me just open my code so that we can do this. You can see it as we do it. So I'll unshare this, then I share the code. Now, so here is my code. I've opened so many files, but I'll just go to, I'll pick one and then we'll use that one for example. So I want to pick the one that is called multiply, is the one I'm using. It is multiply.circom. Yes, I want to see where it is. It's one of these. So this is my file. This is the name of the file. And so the code, the simple code is here. We understand this code I explained last time what it's doing. Of course, it's getting, supposing somebody said he knew the factorization of out here would be Z. So let me say that Z product of these two. So supposing somebody says he knows what Z is, then this person is supposed to give us what these two are. And so we have said signal input, where you just put in your inputs, and then signal input B, signal input A, then signal output Z. Or I've called it out, signal output out. Now, so this one we had already done. So what we want is, today we want to create witness. So I had already said we go to the terminal. Then while at the terminal, you run the command circom multiply.circom, then dash R1CS, then dash, there's some space, and then again, let me just do that. This is what I'm, okay, that is my command, circom multiply.circom. So what this one does, it will generate some files. It will generate this, generate the simp. We are much interested with the WASM part, which will then generate multiply_JS. So I run this. Oh, just a minute. I've done, what I've done is, we're supposed, first of all, before I run the command, I'm supposed to cd circom, so that we are inside circom. So cd circom, that is what we said last time. Before you do any command, you do any command, you must be inside circom. Then when you are inside Circom, now you can get, you can now write your command. And so when you do that, it has now done it. So that is a mistake I had not, I was supposed, first of all, to be inside Circom before I write a command. Now, so when you do that, it has run, this is the output. So it gives us, when you do that, template instance one and so on, public inputs, private inputs. Private inputs, there are two. So A and B, because this person claimed to know Z, want this person to prove that he knows what Z is by, first of all, giving us what the witness is. So our A and B are private. Our A and B are private. So this is what this person will be. So whenever he says he knows what Z is, he's supposed to give us A and B, not the real ones, because he's not supposed to reveal what Z is. He's not supposed to reveal what Z is. So he's just giving us a random A and B. And then we verify whether A and B gives us Z. He also gives us that. So A and B are private. That is what we are saying. We're seeing here that we have two private inputs and we have one output which is public, Z. Z is public, so on. So it has successfully written, and that is what we said. We said to give us three files. The first file is R1CS, and then the simp, multiply.simp, and then we have, and very much interested with this, the multiply underscore JS. Now, so when you check here, you can see them. When you check on our left, you can see them. You can see we have multiply underscore JS here, where I'm pointing. And then this other one is rank one. It's just one of, it must be here. It's here, down here, just below multiply Circom where I'm pointing. You can see we have multiply.r1cs. Then below it, you can see we have multiply.simp. So those ones have been created by the command we just ran. Now, so we want to create witness. So what we then do, we cd multiply underscore JS. So cd, we want to enter inside there, and then that is where we shall now create a file where we will now input our witness. So multiply underscore JS. Okay, we're now inside there. Now, so it's here, multiply, where is that? Multiply, we just check where, it's here. So inside here, we want to create a file where we will now input our, witness. Now I want to call that, file as, in my notes I said I will call it input.json, but you can call it anything but .json. You can call it anything .json, so long as you keep on referring to it if you want to generate the witness, or if you want to prove, or if you want to verify, you must refer to it. Now, so I'm inside here. You can see there is a new file. I've just right-clicked on multiply.js. No, multiply underscore JS. Just click first. So it's here. Then I right-click. We have new file. Then I said I want to call it input.json. So when I enter, it opens where I'm supposed to input my witness. So it opens that. And then now the opportunity to input my witness, and they're supposed to be integers. So that's my witness. Let me even use 4. You can use any number so long as it will give us witness. We are saying, for instance, supposing Z is 42, then this person is telling us that A is 6 and B is 7. Now, so this is our witness. We've now created a witness. You may want to generate it. You may want to generate this witness. So if you want, but one thing you should see is that A is in those quotation marks. Then there is a colon, and then B, the value of A is also in the quotation mark. Then there's a comma, B is there, and then there's a comma, and then the value of B, and that is, and of course you can see you have curly brackets on both sides, enclosing the witness, closed inside those curly brackets. Now, if you delete any of those, and then it will not work. Now, so we want to generate a witness, want to know what a witness is. So we generate, and for us to generate that, we're using node generate witness. I remember we did .json, so let me just write the code. Let me write the code. We are still inside our Circom. Remember we did CD Circom, so it's still there. And then we have also done CD multiply underscore JS, so we must still be there for us to proceed. Then I write the submit. And just copy the command and then put it here to save on time. So it's node generate underscore witness. So we want to generate a witness, a .js. And then the name of the file is multiply and then .wasm. You have to remember input .json. That is where our witness is. So you must remember that. Then witness this is .wtns. That is a short form for witness. When you run that, now we've run. So after running that, you can see where is that? It has okay. So there is some witness. This file has been created. Witness dot this file. Witness dot WTNS has been created. This is where now our witness is. That is where it is, but you cannot see it. You cannot see it if you click on it. So for you to see it, you must export it using the Snacks WTNS. And so that is the command that I want to write so that we can be able to see how our witness looks like. Now we are still inside multiply underscore JS. So I've written the next command, snacks witness or WTNS, export JSON witness dot WTNS. Now, so it has opened some files. There are some files only that you can see this file here. You can see this file. This file. When you look at it, this file is telling you that our A was B, our A was 6, and our B was 7. It has calculated Z, and then 1 is always there in the witness. And that is what we did. A was 6 and B was 7. So when it does the computation, it has calculated Z for us. Now, if there was an intermediate value, then it will still do it for us. If there was an intermediate value, it will still calculate that for us. Now, but we want it displayed somewhere. So we don't want to just be coming here and then clicking. So I will then say cat witness.json, cat for the cat. So if I put that as a command, cat witness.json, what do we get? It displays our witness here. So because we didn't want to be going there and then reading from there. So it displays our witness here. So this is our witness. can see these are the entries we had put. A we had put to be 6, and 7 we had put to be B. This was our B. And so it has gone further to calculate Z for us. So this person claimed to know what Z is. So if he's telling us Z is 42, he's giving us A and B as 6 and 7. So if you ask him again, he may change the values, he may change. So if you change, let's see what happens if we were to change. Again, if we were to change, it means you have to move a step upward again. Because if you, let me see, what if you just say cut witness at this point? You see, we have to go up so that it again computes this. You have to go up so that it computes this. We've said now this time we want our A to be 8 and 9 to be B. So it means again you have to climb up the previous step, which was node generate witness. So you must again go back to that. So let's just do that. Node generate witness. So when you run it, then you run a snack.js witness. Snack.js witness, that will be the next. So again, let's do that. Okay, now it's the time now you can want to run cut witness, so that it now gives you the witness you just entered. Now, so you can see it has changed the values. It is now telling us that A is 8 and B is 9. And at that point, it's telling us that then Z becomes 72 because it's the product of these two. One is always there as the first entry when you're writing a witness. Now, so this is the first thing I wanted us to look at. How do you create and generate witness? So from there, then we have to go to how do you prove, how do you verify, and so on. Now, so the first bit of what I wanted to cover is that creating a witness, just understood what it is. I've explained from what I was displaying that what A is, what B is, and that is what I'm just trying to explain. Now, so before you go to proving and verifying, sometimes you may want to make some inputs public and others private. So that is the bit I want us to look at. How do you make some signals private, others public, using Circom? But what I know is naturally, without declaring them public, they are private. If you don't declare them public, then they'll be assumed to be private. But if you declare public, then they become public. But without declaring, like the ones I've just written above, they are all private. Now, as I've said, in certain cryptographic protocols, especially those involving zero-knowledge proofs, we may want to make some inputs public, and I've given a reason, one motivation, why should we do that? Now, so I'll take you straight to how do you make them public? How do you make them public? And I'll show it by this example. This example I've written I've written a circuit here. Now, this circuit, it aims to show that the our out is a product of ABC. Our out is a product of ABC. Now, so this, since this is not in a rank 1 constraint system, because it has more than one multiplication, we must first of all convert it into rank 1 constraint system. So for instance, we want to call AB, A times B to be V, so that now out becomes B times C. So now we have input Z, A, input B, input C. And then we have the intermediate value. That is not an input. So it's just signal V. And then we have the output, out. Then you now give us the equation that gives us V, and give us the equation that gives us out after you have V. Now you want to declare A and C to be public and the rest to remain private. So that's what I've done. So this code, then it comes up to here. So you can see I've said component main. So and then I open bracket. Public is A and C inside this bracket, and then again I close with the curly brackets, is equals to public, some public. Now, so that means without this statement, if you are to stop here, and then everything will be taken to be private. Everything will be private. But in this case, I've decided that I want A and C to be public, so that the verifier, so I'm the prover, for instance, the verifier, I give the verifier this knowledge. The verifier also has to know what A is and what C is. And then I withhold B, so that he does not know what B is, and he does not know what the out is. So our out is private, our B is private, and the verifier only knows public knowledge, which is A and C. Now, so again, the process of writing this code is just the same as we did earlier. So when you're writing this, just do it as we did earlier. So for instance, I can just copy this and paste in our previous code that I've been explaining. Then I begin nodes and so on. The node, the process of generating a witness. So I can just copy this, paste in our earlier code, and then begin the process of generating a witness as we've done in our previous example. So the only difference between this code and the earlier one is that I've declared some to be public and others I've left them that way, which means they're private. So I've said signals A, B, and C are declared as inputs. Of course, those are inputs. Now, after that, V is our intermediate value. So it's not an input. Just say signal V. Just say signal V when you're writing this code. Then the out is an output, signal output. Then I've said that this is the key point is that component main is because that declares these two as public. So this line declares that only A and C are public inputs, while C remains private from another person. So it's only the prover. It's only the prover who knows what B is. Now, so let's write our witness again. Let's write our witness. Just go through the same steps as before. Let me share the code. Now, some public, I had already, I have that file, some public dot Circom. Just looking for where it is. Some public dot Circom is here. So this is the code. This is the code. So you can see I already have A times B giving me V. This is our intermediate value, and it's here signal V. And then C times V giving us out. And then I've declared A and C as public. Now, so I'm inside, I have to go inside some public. I have to CD that because we want to begin a process of writing a witness. So I have to CD that. I should be inside that for me to write a witness. So CD somepublic.com. Oh, just a minute. That's not the correct thing. First of all, you have to CD Circom. CD Circom. Once you enter that, now CD somepublic.circom. Is that? Okay, CD Circom. I think maybe I'm not writing that spelling correctly. Then CD some public. Oh, it's supposed to be CD some public. Some public. What is that? Let me just look at this. Cannot find. I think it's a spelling that I'm not writing properly or what. Why is it not finding it? Okay, let me again write it. No, we don't need to. Okay. I'd forgotten the steps. Let's first of all CD Circom. Yeah, that's the first thing we're supposed to do. We're supposed to again CD some public. Let's CD Circom. And then after that, want to generate proof. So it should be Circom some public. That is what we're supposed to do, yes. Let me just write it here so that I can copy it from here. Some public. So this is what I'm supposed to run, not to CD some public. So when I run this, it's supposed to generate, yes, that's what it's supposed to do. It's supposed to generate it's telling us that we have two public inputs, and of course that is true. A and C are public. And then The private one is B, it's just 1. And then public output is 1. Public output is 1. So how many are those? Okay, it's just 1. Then it's telling us it has generated public dot R1CS, and then the simp and some public dot underscore JS, and that is what we are interested in. We shall go inside there and create our witness. So let's cd some public underscore JS. Let me just copy it here. Okay, so let's find it from our left side. Some public dot underscore JS. Let's just find it. Then we create a file inside that. Some public, it's here. Some public underscore JS. So inside here, I want to create a file, and I call it input dot JSON. Okay, it has given us a place to type. We need to type our witness, our inputs, only inputs, and then it will generate a witness for us. So let me say, for instance, we say A to be 3, B to be 5, and C to be 7. But it knows that A and C are public. It knows that. So let's see how we then generate this. So the next thing we need to do is a node generate underscore witness. That is our next command, as we did before. Let me just write it here and then copy it from there. It's supposed to be node generate witness. This one is supposed to be some public, because this is the name of the file. Some public. This is the name of the file. So that is the only difference, but the rest is like the one we used earlier. So if I put it in our terminal and run, it generates some files. Let me just see. Where is witness dot? It should be this. And see, it's not open. You cannot open it. So you must run the snacks command, and that is what will help us to open it. So we run the command, the snacks, the command in this terminal. We run it. Snacks, snack.js WTNS export JSON witness dot WTNS. Okay. Now, then the last thing is now to use cut witness, that we can now have our witness displayed to us. Yes, it's here. It's telling us that A was 7, no, A was 3. This is C. C is 7. And then B is 5. And it's telling us that intermediate value 15, that is A times B, A times B, A times B. This is A is 3 and B is 5. So the product is our intermediate V, which is 15. So you can see the public values are now together. A and C are public values. And this is our output. When you multiply ABC, you get this output. 3 times 7, 21. 21 times 5 gives you the output. So this is our witness. These are our witness. So it's able to display for us the witness. But remember, 2 of these are public. So that means the verifier knows them, but the rest remains private. So this guy, if he says he knows what Z is, he'll be giving us the public values, but then the private ones will be changing them, changing the private ones. Every time you ask, he gives a different B at every time, and then a different B will be giving you a different Z. Different B gives you a different Z, but now A and C will be public, so every time will be giving you 3 and 7 because they're public. Now, so that is just an example of how to make some public and some private. But remember, if you don't declare the public ones, then it means all your inputs are private. That is what it means. If you don't declare the public ones, then that means that they're private. Okay, so that's what I wanted to show you. Now, so we looked at how to make some inputs public, and the explanations I've already given. And I've showed you how to do that until you generate witness. So these are the commands. These are the commands we've been using. Circom multiply.circom, R1CS simp. Of course, you can also add wasim here, wasim. Then after that, you would then use snack.js, R1CS print some public dot R1CS. And so this then gives you where to write your witness. Yes, this is what I was referring to. You must have this. Then it will give you this multiply, not multiply. This time it will be called sum public underscore JS. Sum public underscore JS. And then you CD this. You CD that, you be CDing, you CD sum public underscore JS. Then inside there, create a file, which we then call input.json. And inside that is where you declare your inputs. Declare your inputs. Then after you declaring your inputs, the next step will be now to generate. You say node generate underscore witness dot JS sum public dot wasim input dot JS space witness dot WTNS. Now this one does not, it will just create some files, but then you will now want to run this snacks WTNS export JSON witness dot WTNS. Then after that, you do cut witness. That is the last command, and all the witness will now be able to see what the witness is. And this example, and this will be our one, which is always there. And then the output, this is A, this will be C, and this will be B. Remember that A and C were public. And then this will be B, and this will be the intermediate value, or intermediate value. So that is how you then do it. That's how it will be done. Now, our next thing, what we want to look at is how do you prove the circuit? How do you prove that it's correct? Or how do you, then after proving, how do you verify? So that is what we want to look at. I'll again take you through an example of how that is then done. So I've said after compiling a circuit and running the witness, after the witness has been, you've seen what the witness is, it has been generated. Now that, when you run that, it gives you this WTNS and this. And this has all the inputs. And not only inputs, even the output and intermediate values as we've seen. It contains the witness. And the witness has a 1, has the output, has the input signals, it has the output signal, and then it has the intermediate values. So that is what WTNS contains, .WTNS. Then this other one contains the rank 1 constant system representation of the circuit. So we have the circuit, and this circuit is supposed to be written in a rank 1 constraint system. So that is what is contained in .R1CS. Now, so for you now to prove, if you want to prove, we use growth 16 ZK SNAC protocol. And this, we use it to, we're not going to the details of growth 16, you can read about that, but we'll be using that to construct and verify the proof. So growth 16 requires a trusted setup with the 2 phases. So first of all, I'll take you through the first phase, then I take you through the second phase, and at the end of the second phase, you'll be able to see how to prove and how to verify our proof. So the first phase is what I call, or what is called, powers of tau. And the second phase is the circuit specific phase. Now, so what do we do in the powers of tau phase, or phase 1? We start the ceremony and we write this command. So this is just given the commands that we'll be using. So we write this command. And then after writing this command, that is snack.js powers of tau new BN 128. Then you come to this other command, contribute to the ceremony. So you contribute to the ceremony by snacks.js powers of tau contribute. So you see, this part is just still the same. The only thing that has changed that this time we are now contributing, and it goes up to here. This command goes up there. So I'll be showing you how those commands will then be working and what what they'll be generating at every point. Now, so that is the end of the first phase. It has only those two commands. Then we come to the second phase. The second phase, this is a phase that we are now preparing the proof. So we have the snack JS powers of tau prepare phase 2. The command goes up to here. And then the last command is generate Z key. And it comes up to here. That is the command, the second command in the second phase. Then we have contribute to second phase, phase 2. Remember we had contribute to phase 1. So this time we are contributing again to phase 2. And then after that, we export verification key. After that, if you had not gone through this part, you can still go through it. This is the part we are creating input.json, our witness. If you had not done it, you can still do it at this point. And then run the witness generator. Run the witness generator by this command. We've been using this command node. So this is, we are inside multiply underscore JS. That is if the name of your file is multiply. You can see we have had several names. Like in our previous example, our file name was some public. So but the first example was multiply. The name was multiply. So you can see we still have multiply. Then generate witness.js, multiply underscore JS, and so on. Now, in case you encounter any problems and you need to do some troubleshooting, you can do it by just verifying whether these 3 files were well generated. Now, if there's no problem at that point, it means your circuit is okay. You can generate proof by this command. You can generate the proof by that command. And if that process goes properly, then you can verify the proof. So this will be the command for verifying the proof. And that will be the end of it. So I want to take you through those steps one by one, so that we do it together. So just begin from phase 1, go to phase 2 as we progress. Now, so let me share my code again. Now, first of all, I'll again use the first example, multiply.circom file is the one I'm looking for. Multiply.circom. It was down somewhere here. Multiply, yeah, this. So we've already generated the witness. We have no problem. It had given us a witness. So let me just open where the command starts, where we move step by step. I'll just be copying the command and just a minute. I'm looking for where the command are so that to save on time, I'll be copying and then just pasting. Okay. Now, so let's begin. What was our first step? We said we come to FS1, powers of tau. We have the command snark.js, powers of tau, new bn 128. So that is what okay, so look at our terminal. We are inside some public underscore JS. So let's get out because we want to want to be inside multiply. There's no problem. We will come inside multiply later on. There's no problem. They can begin. Let's just be inside Circom. But this is the command, powers of tau, new bn 128, 12, 12, 4 zeros, dot p tau, then minus v. Now, there's some information we've just received. It has given us, it ran successfully. It has said calculating first challenge hash, calculate initial hash, and so on. So this is what you get when that is successful. Now, so the second part is you contribute to the sermon. That is the second bit. Contribute to the sermon. Now, so the code for that is here. This is same. This is one one code. So the only thing is that at this point, you type your name here. You type your name here, or you can even type anything unique. There's no problem. It's not necessarily your name, but it could be something unique. You just type there my name. Just anything unique. You type there anything unique. There's no problem. It is snark.js, powers of tau, contribute, and so on. Now, so it has said enter a random text. Again, here you just enter anything unique. Let's say a lesson. Let's say lesson. Then if it's successful, you can see it's giving us some output. It has finished. So this is what you get if it is successful. Now, so that is the end of the first phase. So we got the second phase, and the second phase begins with the snark.js, powers of tau, prepare phase 2. So that is what we want to do. We want to prepare phase 2. And again, I just copy the code and then I'll paste it. So this is the code. Just ensure that it's a one code. Now, so this is snack.js, powers of tau, prepare phase 2, 41, 2, 0, 0, 0, 1, tau, and so on. So this is the code that I now copy and paste here. Now you can see it's again successful. Okay, so just wait until it runs to the end. Just give it time. Yeah, it's taking some time, but can be patient just for some few minutes and see what if it will be successful. It's after that that we progress to the next step, because we're supposed to prove our circuit and then verify if it's correct. So yeah, we have no choice but to wait until it runs to the end. Yeah, finally it has run to the end, so it's successful. So the next step would be to generate the Z key file. Generate the Z key file. That's the next step. So the code for that is here. Now you can see the name of the file is multiply. So it's correct. Yeah, it's the name of the file. Otherwise, if you are using the sum public, you would just change that to sum public. But we are doing for multiply.circom file. So I copy it, paste it there. Okay, it has already run. Successful. And we have some output. So after that, we contribute to phase 2. We contribute to phase 2. Contribute to phase 2. So the code for contributing to phase 2 is here. Again, you can see that we are still in the right file, our multiply file. So we just want to, you can change this to your name, or you can just leave it the way it is. First contributor name, there's no problem. and paste it here. Now it's successful, so it's asking you to write anything random. Say enter random text. We had entered lesson last time. You can enter that or even anything new. There's no problem, but it should be just a text and then enter. Okay, again, that phase is successful. So you contributed to phase 2. What we now want is to export verification key. That's now what we want to export verification key. Let us see what the verification key looks like. Because we want to export that and we may use it now to prove on-chain and so on. So we say Snacks, Snack.js, zk export verification key, multiply and so on, verification key .json. So again, I just paste it there and then run. It says export verification key has started. Detected protocol growth 16. Export verification key is finished. Now, so where is that key now? So for you to do that, for you to see the key, supposing we are not created input.json, you would do it now. Supposing you're not created it, you would do it now. But since we've already created, let's skip that and go to generate a proof and see whether it will work. If it doesn't, we'll still generate, we'll still go through the process of .json. Or we'll just troubleshoot. We'll just troubleshoot and see where the problem is. So I want the code for generating a proof. It will work. If it doesn't, then we shall troubleshoot. Remember, I said if you find a problem, then you can troubleshoot by some code I had already specified. Now, so to generate a proof, we shall use this code. We shall use this code. The code is Snack.js growth 16 proof multiply 001 dot that and so on. That's is the code that I want to copy and paste it here. If we find an error, we shall troubleshoot. There's an error. It says invalid length circuit. Okay. So it means that the witness in our .json is not the same as the one we are trying to get. So let's troubleshoot. Let's just use Circom multiply first of all. Before we do the command, we just done. Okay, so you can see I have refreshed my terminal and we are out of Circom. So let's again see this Circom first of all. See this Circom. Now we want to generate, we want to verify our proof. Let us CD multiply. Let's see first of all if this will, what happens if we do this multiply JS. Let's CD that. Let me repeat the code the one that I just done and gave us an error. Let me just do this and see whether it works. So that if it doesn't, then we will have to troubleshoot. Okay, we still have an error there. It's no problem. Let's come out of multiply underscore JS. Let's now troubleshoot. Let's just troubleshoot. This is the command I want to use to troubleshoot. Circom multiply.circom and so on. Okay. Okay, so I'm assuming that after running this, I'm assuming that now you can see our wires are 4, labels are 4. That is what it's supposed to see. If it doesn't, then it means there's something, a problem. We begin the process of again writing witness afresh. Now let me again do this command now for proof generation. Because it's supposed to use a witness, to generate the proof, and that is why we have done the troubleshooting to see whether our witness is correct. Yeah, there's still an error, and it says invalid witness length. Circuit is 4, witness 6, and so on. So that means it's not reading our witness properly, where the witness is. So let's create a witness. Let's create a witness again. Let's use the same process of we had used earlier to create a witness. CD Circom. Just want to go through the process of creating a witness very fast. Of course, we've already finished phase 1. We finished phase 2. So we will not repeat all of them. Just create a witness and then we come back and do the proof. So I'm just going through the process. The process of creating a witness, you have to do Circom multiply.circom and that. Now what? Something I forgot. Okay. I went too fast. I went too fast, that is why. Again, do it. I don't know why it was not accepting that. The same command that I just used. So we're still going through the process of creating a witness, which we had done earlier. So you see d multiplied s underscore js, which has been created. Then inside that, multiply inside multiply for multiply underscore js, where it is that we create our witness. It is here. Input just so we input our witness, our inputs. And multiply, we are only dealing with the two. So this is the two inputs, A and B. And after that, we generate using node generate. So of course we had already done this process, but when we came to run, it did not run. Sometimes it requires you to again do the process repeat. I don't know why. Then we do the snark witness.js. Okay. Then we do, you can now want to see our witness, but there's no problem. We've already seen how witness is generated when you use cat witness.json. So this is our witness. So let's again try our steps for phase one. Let's just do it. Phase one. Let's just begin afresh for phase one. There's no problem. Phase one, we began by snarks, our hours of tau. So that is the code I'm putting here. Okay, it has given us that. Then the next one is where we contribute, and it is here. So here we just write any unique text. We had already gone through these steps. Then the next thing, we now prepared for phase 2. Now prepared for phase 2. So wait for it to run. Then after it has run, we go to Snack.js growth 16 setup. So we wait for it until it's done. We prepare the next code. Snack.js growth 16. So this is the next code. So we'll be patient and wait for it to just run to completion. Now it has run. So let's run the next code. Next code does what? Oh, I've been working inside multiply underscore JS. I've been working inside that. Since I've been doing that, just continue to the end. Okay, this is the code I wanted to run. It has not run. Coming outside that, let's see whether it runs. So that means it wants to be outside, not inside multiply. So let's be inside Circom then as we progress. And then from there, let's contribute to the second phase. Let's contribute to the second phase. So when you paste the code here and run, gives us a place to write a unique text. I've written that. Then it runs. This place is now to export the verification key. We are almost where we reached when we began afresh. Almost there. So let's hope this time it will run on the first attempt. So when I do that, everything is okay up to there. Everything is okay. So let's go straight to generating the proof. This is where we reached, and then it refused to. It told us that the witness we were working with was different with the one we were proving. Again, it's saying the same thing. Saying the same thing. So okay, let me try to run this other code and see what we get. I don't know why this part is not running. Again, troubleshoot. And again, troubleshoot using this. I think it gives us. But now when we come to the part of generating the proof, I don't know why it's not working. Okay, so since it has not accepted, I think maybe I can stop here and then I look at it. That is the command. I'll check and see why the witness that we entered, the length of that witness is different from the one that we are proving. So it means it's not seeing the witness that we entered in our input.json. It's seeing something different. I think it's seeing, since I have different input.json, maybe it's seeing this one that has a different input length, witness length. I think that's what it's seeing, this input. And I have this one. So maybe that is maybe a problem of having several of them here. Because I have several. I also have another one here. So basically, maybe it's saying one that is not correct. So that is what I then want to find out. So let's stop there. The next time we revisit the proof generation process. Thank you.